All right, we're in AP Calculus. We are doing self-check 3.3 today. What's going on with my computer? There we go. All right, so today's date for the record is Monday, October 26, 2020. The function looks like that. We need to figure out if it's increasing, decreasing. All of these are increasing and decreasing, so it helps us to define what those are. So F increasing, Andrea, is... There it is. And Teflon, F decreasing. F prime is less than 0. So we need to find F prime. That's what our definition is telling us. So if I come down here, F prime of X, that's going to be equal to, Chris, take the derivative. So the 3 comes down in front, right? 3x goes down to a power of, yep, minus 12. Okay. And the most helpful thing to do with every derivative is to factor it as much as possible. So this one can be factored as 3 times the quantity of x squared minus 4. And it doesn't really help us that much, but there it is. Okay, so, oh, wait a sec, x squared minus 4, that can be factored further. Anyone see x squared minus 4? That can be factored into what times what? Difference of squares is conjugate pairs. There it is, yeah. So this is 3 still on the outside, x plus 2 and x minus 2. All right, perfect. So there it is. It helps us to find our CVs, which means I'm going to do what, Fiona? Plot on the x-axis. Yeah, plot what on the x-axis, though? The CVs, and how do I find the CVs? Make it equal 0, yeah. So 0 is now equal to this 3 times the quantity of x plus 2 times the quantity of x minus 2. And let's go ahead and make Fiona's x-axis come over here. Let's put it right here, just in case we run out of room. So I'll say that is indeed our x-axis. Andrea, can you solve Fiona's CV equation? Yep, okay, cool. Let's graph both of those. I have -2 and 2, label them both CV, CV. Notice that both of these factored pairs are to the first power. They're to an odd power. They're to the power of 1, which means they're going to switch signs over each of these CV jumps. So let's plug in one nice value, Teflon. What's the easiest value out of all of these numbers to choose? I think 0 is even easier. But you can plug in 1 too if you want. I'm gonna do 0. So when we plug in 0 Teflon into this factored form right here, I guess I can circle the blue. What do we get? Positive or negative? Negative, yep, because we get, this is always a positive, this is going to be a positive, this is going to be a negative. Positive times negative is a negative, which means this is going to be an F decreasing. And as I said, every time that you jump over CV, it's going to switch signs, so it's going to be a positive. Anything greater than 2, negative anything less than 2. Therefore, wait a sec, that's not jumping. There we go. Positive everything left of -2. And we're trying to figure out what is happening here. So increasing for x is less than -2, decreasing between there, and then increase. This is literally describing this graph right here. The correct answer here is A. All right, fist of 5 on number 1. 4.5, 3, 4, 3. Okay. Any questions? Then we're moving on to number 2. Oh, it gives us the derivative already. Okay, so the derivative is this thing. How many points will the graph have a relative maximum? So let's go ahead and define that. F relative maximum, or an F maximum, it's kind of the same definition, is what, Chris? Yeah, F prime goes from a positive to a negative. That means we need F prime and we're given F prime. Cool. So in order for it to switch signs, we need to verify that it's to an odd power. And this is to an even power, so it can't switch signs over there. It can only switch signs over the over 2 and -3. So our only possible answers are none, 1, or 2. I can immediately eliminate options D and E. There's no possible way. But we do need to make a number line for this, our x-axis. All right, so Fiona, I made my x-axis. Where should I draw my CVs? What numbers are our CVs? Yep, so say -3, 2. What is a good number if you wanted to plug in? CV, yep, let's plug in 0. So if I plug in 0 right here, is that going to be positive or negative when I plug into that derivative, Fiona? Yep, negative, because that's always going to be a positive. This is going to be a negative. That's going to be a positive. So we're going to have a negative there. And then when it jumps over those CVs, it's going to switch signs to a positive and also to a positive on the left-hand side. It always switches over those CVs. I guess we should have also graphed. I know that this is not technically correct. I know when we plug in 0 to this entire derivative, the answer is actually 0. But again, we can kind of ignore him because it's not going to be any relative extrema. So it's a little bit cheating to do, but that's fine. And again, I'm switching from positive to a negative. So Andrea, the answer is, where are the maximums? Tell me, is it -3, 2, just 2? -3. So the answer is 1. Yep. So this is our maximum. And there's only 1. Fist to 5 on number 2. 3, 3, 3.5, 2.5. Questions, anyone? Okay, moving on to number 3. We have this graph, and we're trying to find where it is concave down. So it helps us to define F concave down, Teflon. F double prime less than 0. Thank you. So we need to find F double prime. We're given F, so we have a lot of derivatives ahead of us. Let's go ahead and find, I guess Y prime, I guess is F prime, right? Y prime, give it a Teflon again. Take the derivative. X squared, yep. There it is. All right, and we don't care about the first derivative. Aside from it helps us to find the second derivative. Chris, second derivative, go. Take the derivative again. 3 comes down in front.
36.
Yep. Minus 96. Just double 48. Yep. X plus 48. There it is. Thank you. And then we need to factor this thing. Fiona, you're up. Greatest common factor. Factor it out. Two goes in all of them. 3 goes into all of them. That means 6 must go into all of them. 12 also goes in all of them. I think 12 is a GCF. So when you factor out 12, Fiona, what's left over? Eight. Yep. Plus 4. All right. Thank you. All right. We have this as factored as possible. It's time to actually we can factor even more. I bet that can be advanced ninja starred. Andrea, can you help us do that? Or sorry, can you say it again? Up here should be. Usually we put it. I mean, it doesn't matter as long as you know that it adds up to -8. It doesn't matter where it goes. This is just a tool. And then 12. And we say 3x and 3x. Perfect. And then The question for the entire class then becomes, what two numbers multiply to 12 and also add up to -8? And the answer, Andrea, is -2 and -6. Yep. And we're not done with the advanced ninja star because we have to reduce both those fractions. So let me move this advanced ninja star over just a tad to the right. Give me some room to write. These are kind of like the needles of the advanced ninja star. So 3x and -2 can't be reduced, so I don't really need to worry about him or her. And then 3x and -6, Andrea, to finish it off is -2. So that means if I come down here, our true factored form for our second derivative is 12 times the quantity of 3x minus 2 times the quantity of x minus 2. Whew, all right, that's still the second derivative. It helps to have it factored because it makes your life really, really easy. Let's go ahead and make our number line. All right, Teflon's up. What question do I have for you? Let me set up my number line first. This is my x-axis. What are the CVs, Teflon? Or I guess potential inflection points. They're not CVs. CVs is for first derivative. Yep, so say 2/3 and 2. And they're, with the first derivative, those are critical values. There's not a name for them for the second derivative aside from potential inflection points. We now need to find what's happening in each of these intervals. I would like to point out that both of these factors are to the power of 1, which means they are odd powers, so they should switch signs over any given interval. Let's plug in the easiest one. Chris, what's the easiest number to plug in? 0 is typically always going to be the easiest one, unless otherwise, yes. So I should also, yeah, I'll be careful with my color coding here. Well, let's try plugging in 0. When I plug in 0, 0 makes that a positive, 12 is still positive. What about 0 for the 3x minus 2? That's going to be a... What's 0 minus 2? Yeah, negative. Yep. Okay, and then for this third one, negative. So in total, it's going to be a positive. Yeah, positive times a negative is a positive. So we'll say that's a positive. And we know that it's going to switch signs because it's an odd power. So we can say this is going to be a negative, and then it's going to switch back again to a positive. Okay, so we're looking for what's concave down. That means it's less than 0, as we defined earlier. That's between negative, or between positive 2/3 and 2. So how do we say between 2/3 and 2? It looks like the correct answer here is E. Fist of 5 on number 3. 3, 3, 3, 3. All right, any questions? No? Okay. Moving on to number 4. We have this function. We're looking for points of inflection. All right, so it helps us to define what are points of inflection. F, inflection points. Fiona, go. Sign change. So we have to find F double prime. Let's first find F prime. So F prime of X, Fiona. Did you say negative? Okay, sorry. Say it one more time. I didn't hear all of it. 5x to the power of 6 divided by 7? I cannot hear. Okay, sorry. 35. 35x to the power of 6 divided by 7 plus x to the 4th plus 1. All right, thank you. And then before I go on to Andrea, 35 over 7 reduces to 5. Yep. And another way of seeing that is when I have the 7 that comes down in front, the 7 and 7 cancel each other out, and I'm just left with the original 5. That's why I thought you said 5. So I'm going to go ahead and be crafty like that, and I'll say 5 is still there. And then, Andrea, find the second derivative. Yep. There it is. And then we should factor the second derivative here as well. What's the greatest common factor, Teflon? Yep, 30x to the power of 3. And when we factor out that GCF, you're left with plus 4. Yeah, there it is. And then we can still factor this. We can either use advanced ninja star, or you can recognize that it's a perfect square. Either way, let's go ahead and pretend that we don't know it's a perfect square. We can use normal ninja star on this because the leading coefficient here is 1. So normal ninja star. Chris, how do I do normal ninja star again? Two and 2, yep. So that means that this really factors as 30x to the power of 3 times x plus 2 times x plus 2, or I can just say x plus 2 quantity squared. All right, and we're looking for f inflection point. Let's come back to the original question. And I'm looking for a sign change. And again, there's a nice shortcut, right? I'm looking for even or odd powers. This is an odd power, which means it is going to have a sign change. This is an even power, which means it's not going to have a sign change. So how many inflection points are there? There's 1, and it's right here. And it's whenever this 30x to the power of 3 is set equal to 0. Therefore, our answer is x is equal to 0, just B. And I can write that down for our notes as well. I can make that a slightly nicer circle. What we said here is that this has, we'll say yes, inflection point. Why? Because odd exponent. So at x is equal to 0 when you solve that. And then I can say over here, no inflection point. No inflection point. Why? Because even exponent. Again, even or odd exponents affect whether or not you're going to have a sign change. That's all it says. All right, fist of 5 on number 4. 3, 3, 2.5, 3. Okay, any questions up to this point? Then we're moving on to number 5. Oh boy, all right, so we have this fraction, and it's asking about f increasing, f decreasing for all of these a, b, c, d, and e's. So it's helpful to define those things. So if you want to define f increasing and f decreasing. And f decreasing is 0. Okay, so that means we need to take the derivative. So let's go ahead and do that. F prime of x is equal to, ooh, I guess we have to come back here. Let me write this a little bit lower. I think I'm going to probably just do it down here. I have a ton of room. F prime of x. We have a quotient, which means we need to use quotient rule. Remind me, Andrea, what is quotient rule? There it is, over low, low. Low D high minus high D low, all over low, low. All right, so Andrea, can you go ahead and do just this first piece, and then I'll give, after the subtraction sign, I'll give it a tough one. X times 1 over x, there it is, minus Teflon. Times 1, yep. And then I can do the low, low, that's just x squared. And I need to simplify this as much as possible, Chris. What's x times 1 over x? Just this piece right here. Anything divided by itself, like 5 divided by 5 is always, yep. So 1 minus, and then natural log of x times 1. That's just natural log of x. And still divided by x squared. Okay, so we need to find our critical values, because if we find critical values, then we can find increasing and decreasing intervals. So I need to, I think it's worthwhile defining what are FCVs, Fiona. Oh, careful. F prime sign change is relative extrema. Yeah. Or F prime DNE. And then in terms of a fraction, Fiona, what does that mean in terms of what is being set equal to 0? F prime equals 0, is that top or bottom equals 0? Yep, top equals 0, and therefore DNE is the bottom. Set that equal to 0. So we'll have two equations that kind of pop out of this. We'll have equation number 1, I'll do that in green, which is 1 minus natural log of x is set equal to 0, and my second equation is set the bottom equal to 0. So x squared is equal to 0. I'll do the hard math. The bottom is the critical value that comes out is 0. Ooh, who can help me with the top though? Volunteer basis. 1 minus natural log of x is equal to 0. Who's got this? Here, I can do a first step for you guys. Are you guys ready? I'm going to add natural log of x to both sides. So I have 1 is equal to natural log of x. Then the question is, what value of x do I put in here such that natural log of that number is equal to 1? And it's one of those things I was talking about. You have to have those log properties defined or memorized. Natural log of, yeah, Andrea? E, there it is. So x is equal to e. Oops. So x must be equal to e. All right, let's come down here and make our number line for x. Say that this is indeed x. And our critical values we found were 0 and e. You can label those CVs. CVs. Okay, and then what is the easiest value to plug in here, Teflon? You can't plug in 0, it's taken by CV. You have to plug in something else. 1, okay, so let's plug in 1. I'll do that in red, I guess. No, red, green. I don't like that. Let's do orange. When I plug in 1, you have to plug in 1 to the top, which is a little bit hard, but natural log of 1 Teflon is no. Natural log of e is 1. Natural log of 1 is one of those second ones you have to have defined or memorized. All right, everyone write this down. Natural log of e is equal to 1, and natural log of 1 is equal to 0. Those are the two values that you have to have memorized. All right, so I gave you the answer for that one. Natural log of 1 is 0. So 1 minus 0, is that positive or negative? Positive. So the numerator is a positive. The denominator, x squared, is going to be a positive or negative, Teflon? Positive. Yep. Anything squared is positive, at least in AP calculus. Therefore, positive divided by positive is a positive, and therefore this is an F increasing interval. Unfortunately, neither of the, the bottom is something squared, so it's going to keep the same sign. Unfortunately, we can't do anything over on the left-hand side. Why? Again, it's one of those properties of a natural logarithm that I was hoping that you would memorize. You're never allowed to plug in the negative value. So I'm just looking at you natural log of x. Whenever I plug in anything negative, it will say, hey, I'm undefined. You're not allowed to plug in anything negative. So if I'm looking at my number line down here, the way that I say that is you can scribble it out. You can say undefined over here. I think I'll just say undefined because that'll help us remember, hey, whenever you're dealing with a natural log function, you can't have a negative value for an input. So I don't have to worry about jumping over this critical value, which it wouldn't have switched because this was an even power, which corresponded to the CV over here. But I do have to worry about what happens when I come over here to this interval over here. And there's not a really good way to do this. This isn't any quantity to some power. It's just 1 minus natural log of x that I'm worried about. This 1 minus natural log of x was that's the equation that gave us our critical value of e. So we have to just plug in again. So again, E is about 2.7. So a good value to plug in is 3. It's a little bit higher than E. If you want, you could put in 100 or 1,000. It doesn't really matter. Anything bigger than E will work. And we'll give this one to Chris. When I plug in 3 or anything bigger into a natural log function, is that going to be bigger or less than 1? It's bigger than 1 because when we plugged in E, which was about, again, 2.7-ish, when we plugged in 2.7 into this function, it spit out 1. So if I plug in a number slightly bigger than 2.7, like 3, then it will spit out a number slightly bigger than 1. If I plug in 1,000, it's still not very big, but a number bigger than 1. So 1 minus a number bigger than 1, Chris, is that positive or negative? So let's just call this thing on a 1.1, slightly bigger than 1. 1 minus 1.1 is negative or positive? Negative, yeah. So we can come back up here and say that was a negative, which means this is an F decreasing. All right, we basically have our answer. So it is, let's read A, increasing for all x greater than 0. No, because it starts decreasing after we hit E, so it's not A. B, F is increasing for all x greater than 1. Nope, that's not even close. Because our critical value is E, 0 and E. F is decreasing for all values, all x between 0 and 1. Again, 1 isn't a number that we care about. It's only 0 and E. D, F is decreasing for all x between 1 and E. Why are we talking about 1? 1 is not anything important. Okay, so it must be E. Let's read why. F is decreasing for all x greater than E. Oh, yeah, that I agree is true. It's not the complete statement because it's also increasing between 0 and E, but I agree that it is decreasing for all values greater than E. That was hard because there are a lot of properties of logarithms that we had to memorize for that one. But give me a fist of 5. If you had to see a problem like this where you had a lot of log properties and quotient rule and all this other stuff happening, how well could you do problems like number 5? 1, 2, 2.5. Okay. Yeah, that one was hard. That concludes this self check. I should go ahead and just pause.